going to look at some reactions that occur with ions. This is the whole reason for deciding what is in the ion form when they are dissolved in water, because it's the ions that react. This top equation is called a molecular equation because everything is written as though they're stuck together like a molecule. We know, though, really, when an ionic compound like this dissolves, it breaks apart, and I can tell this is dissolved because it has the AQ. So this reaction is written as a molecular equation where everything's shown stuck together, but really those are broken apart. So what I've done is I've taken this potassium sulfide, because it is dissolved in water, it's an ionic compound, so it must be broken apart. So I showed the ions that would be forming. Notice that this 2 makes me have a 2 here, because when that breaks apart I get 3 ions. 2 are potassium and 1 is sulfide. So to get my complete ionic, I split apart everything that is a strong electrolyte. And if you'll notice, I did not split apart this. This says solid, and so it is a solid here and it's not split up. This is our precipitate. Okay. So everything but the solid is split apart. These are all ionic. This is the same reaction, and I just wanted to look at what's happening. Both of the reactants were ionic and completely ionized. So basically we had 4 different ions going into solution. That's what's going on here. And 2 of those ions are finding each other. The calcium and the sulfide weren't together at the beginning, but they're finding each other and they're getting stuck together to form this solid down here. And this is our precipitate. Okay, these other ions didn't do anything. They started off, so it's the potassium and the iodide, they started off just floating around like the orange and the yellow, and after the reaction they're just floating around. They do not change at all, and we have a special word for those. We call them spectator ions. So these ions are spectators, spectator ions. So they're not reacting. They're just sitting there and watching the reaction happen. The reaction is the calcium and sulfide coming together to make this solid. So here's the definition of spectator ions. They are ions that do not do anything in the chemical reaction. They do not form new bonds. They remain unchanged. And so our potassium, it's the same before and after the arrow. And our iodide, again, the same before and after the reaction. Those are our spectator ions. And so what we can do is write a net ionic equation that shows what's really reacting, what's really changing. And what's really changing is that we have calcium and sulfide coming together to make calcium sulfide, a new compound. And so we rewrite our complete ionic equation here to include just the ones that react. And so this net ionic equation is kind of what we usually skip to. It is always the reaction that is required to make the precipitate, the PPT. Another kind of reaction that is a double replacement is neutralization. And neutralization is where you have an acid plus a base that are neutralizing each other to get a salt and water. And know this general reaction, acid plus base yields salt plus water. This is the reaction. If it's a strong acid and strong base, it's pretty simple like this, which is what we will be seeing. The salt is actually an ionic compound. So it's like a metal and a polyatomic ion, or a metal and just an anion. So think of salt as just being ionic compound, but the salt is made up from the cation of the base and the anion of the acid. In fact, the word salt is sometimes defined as a neutralization reaction. This is just a summary of writing net ionic equations, and both types that we've looked at, precipitation reactions and neutralization reactions, both work in the same way, with one little difference. The neutralization reactions don't have a precipitate. Instead, they have water forming. Okay, so what you do is you predict the products, and we've done that for double replacement reactions. We look at the charges, come up with the products. You need to identify the precipitate or molecular product. Usually it's a precipitate, and you do this using your solubility rules. The molecular product, in our case, we will see with our neutralization reactions, and it will be water. And then balance. You could have done that earlier as well. Write the ionic equation, and so decide what's going to split apart. And when you write the ionic equation without the things that don't form the precipitate or the water, that is called the net ionic equation. Remember that if there is no precipitate or molecular product, then there is no reaction taking place. And to get the net ionic equation, it's pretty simple if you figure out the precipitate or the molecular product and just show what it takes to make those.